Hello, this is Tony from GreatIdeaz, and in this video I want to walk you through some of the ideas around getting list of objects within trellispark and how we optimize the process of finding and retrieving list of objects. So what I'm going to do is I'm going to walk you through some examples using the server owner functionality, and straight away we can see we have some tables. Now these tables here of roles, attached files, application categories are the simplest form of tables. All they're doing is producing a list of objects, and those objects are essentially just returning the name of the instance. So every instance has an instance name, which is the human readable name, and I can click on this and I will basically see here is the instance record for a role called generate SQL. Very, very simple. Okay, so let's go and have a look at how that role list was being produced. So what I'm going to do is I'm going to go and have a look at the server owner functionality, and we're going to have a look at the definition of that roles table. So if I go down here and I find the functionality concept, on my functionality data model, there will be a child list called roles. And inside this child list, you can see we have a very minimal role definition. All this child list is being told to do is to list the child concept type of server owner role. I don't need to specify any childless columns. I don't need to provide a default stored procedure. All this is going to do is it's going to look at its parent object and say what roles exist within this instance. So within the server owner functionality, what roles exist within the server owner functionality, and it uses one of our GI list instances, stored procedures, to actually just get that list of rows very efficiently. And that list of rows will contain an instance GUID, which is the record GUID of the role that we're looking at, and the instance name, which is going to be displayed in the table. And that's it. If all you need is simply a list of record names, you can set up these child lists just by saying what concept am I going to create as a child concept for my existing concept, and that's it. I'm finished. Job done. Now, not all of our tables are going to be as simple as that. Okay, so if I go back to my functionality here, you can see, for example, the data model tab has got a much more sophisticated table on it. It's got basically information that tells me which tab, which row, which field, the XML element, and so on. So there's basically a lot more detail in the structure of this table. So what we want to have a look at then is, well, how do I set something like this up? How do I look at a list of form definitions or field definitions within functionality? How do I actually get the next level of detail? So let's have a look at a more sophisticated example. So what I'm going to do is I'm going to go back to my server owner. I'm going to find the form definition concept. So all of these forms have a form definition. And again, I can see, these simple tables. So a list of all of the tabs in this form, the instance name builder, but one of the more complicated child lists in this functionality is the field definitions. So if I look down here, I can see here is where this table that I'm currently looking at is defined in the data model. So field definitions is a child list. So let's have a look at this one. So this one is a lot more sophisticated. Okay, so we can see that we're still trying to create field definitions. So if I want to be able to create an instance within this table, I need to say what sort of concept do I want to create. So in this case, I'm going to create a new field definition. And now you can see that I can go into the actual field definition and I can pull from that field definition a bunch of columns. Okay, so these are the columns that I want displayed in that table we were just looking at. And I can also specify which stored procedure I want to be able to get that list of field definitions. Now, by default, your code generation step is going to create a bunch of these stored procedures for you. So let's have a look at what the code generation step would create. So by default, any concept that you create within your data model and then run code generation will create a number of objects. One of those objects will be a simple getList function. So in this particular case, we've created a function called get. ZSO is the prefix of server owner, and field definition is the name of the table. And this function will always have these three parameters. So we will always have a session GUID and a user GUID. So the user GUID is assigned when your user has joined a workspace. The session GUID is assigned when your user enters a workspace after logging in. And we're going to use those two to actually validate that at the point where this store procedure is being called, that you are a valid user of this workspace and that you have a valid signed in session. Next, what we want to do is we want to actually validate that you have read access to the data you're trying to look at. So in this case, we're using the session GUID, the user GUID, and the instance GUID that you are currently displaying to see, do you, as a user, have access to this instance at this time? And so what it's doing is it's going in, it's looking at the instance access records, and it's saying this user has or does not have access to this instance and can see a list of child records. So again, by default, what's going to happen is that we are going to select all of the columns from the view that was auto-generated for this table definition. So let's have a look at what that view would look like. So this is the view that was automatically generated for the server owner field definition. And essentially what's happening is that there are some standard fields that we're getting from the instance just by the fact that this is an instance. So where does it exist in the hierarchy? Who is its immediate parent? What is the instance GUID of this particular record? What's its name? What's its status? Who created it? When it was inserted? And so on. Okay. So this is all baseline data that's available for any instance. So the view also shreds the XML elements of the XML data that is available for a field definition. And all of these rows are then returned in this view object that we see here at the bottom of the screen. Okay, so this is a list of 1,000 rows out of our field definition table. So what we're going to see here in the select is that we are going to restrict all of the possible field definitions to only show me field definitions where the parent of the field definition is the form definition that I'm currently looking at. And by default, the code generation will select these and sort them by instance name. Now, for this particular table, that's not really what I want. I don't want these fields sorted by instance name. I'd rather that they were sorted by the tab and the row and the field location. And also, because I'm doing this a lot of times, I don't necessarily want to be shredding that data on a regular basis. So I want to use our lookup table functionality. So I've marked the server owner field definition as requiring a lookup table. So what I can do is I can go back and I can create a custom store procedure to use a lookup table to optimize the selection and sorting of these field definitions. So let's have a look at how I'm going to do that. So first of all, I'm going to use code generation and I'm going to set a lookup table on field definition and I'm going to generate and populate a lookup table. So what I have in my database now is I have a lookup table. We use LU for a lookup table, and again we use the prefix ZSO and the table name field definition. So from the code generation for creating and indexing lookup tables, this would be a standard naming convention. And then as part of the creation of the lookup table, I would indicate which fields am I going to query on or show in my tables. So here again, you can see that I have got a list of standard fields that I'm pulling from the instance. And then here, what I'm looking at is a set of fields that I'm pulling specifically from the XML instance data. And I'm going through the XML shredding process to pull these values into a lookup table where they can be indexed and sorted and filtered in the same way that data from any other table in SQL Server is created and produced. But this way, I'm creating essentially a read-only lookup table. So this information in here is only being read. I am not updating this information so that I could write it back to my instance data. This is a one-way trigger. I update the instance in the instances table. That data is then shredded and a row is added into my lookup table, and I can use that lookup table now to optimize any searching, querying or listing of this specific subset of the columns of the field definition table. So how does this look like in code? So here is a custom version of my get ZSO field definition table. And what I've done here is I've added subscript to this stored procedure name so that I know what it's doing. So in this particular case, I've taken my original get ZSO field definition and I've said I want a special version of this, a custom version of this called sort row column. I'm still going to want to validate the session here. I know that this stored procedure is only ever going to be called in the context of producing a list of field definitions for a form that I have already validated the user has access to. So I'm going to skip the validate access check here. And now what you can see is I am going in to my lookup table instead of my view. So I am already selecting from a subset of all of the possible instances only field definitions. I have an index on my parent GUID, so I've restricted my rows very quickly here to just those field definitions rows on this particular form. And because I'm using the lookup table, I am only selecting a subset of the available columns. And in this particular case, I've also changed my order by clause. So instead of looking at the instance name of the field, I'm actually sorting it by tab, row, and then the field value from the XML element. Again, this stored procedure has the standard set of 3 parameters. So session GUID, user GUID, instance GUID. So whenever you are going to create one of these custom getList functions, you need to make sure that you're passing exactly these 3 parameters. Now the result set that comes back from this stored procedure is going to have the instance GUID, and this is important because you're going to need that instance GUID if you want to click on the record to select it. It will also have parent GUIDs, instance names, and so on. So these are the fields that basically it's picked up from the main instances table. And then it has these data fields here. So data type field, field type, labels, lookups, required fields, and so on. Okay, so these fields here exist in the lookup table and are being returned. Now, they are then being referenced here. So this is the stored procedure that I've just shown you. So this is my custom stored procedure where I've returned my rows sorted by row and column. And then inside my table, I have defined the columns that I want to show in my table. So here, for example, my first column, so column sequence 0, I am looking for the XML field name called tab. And that corresponds to the tab column that's being returned in this data set. This particular column type is numeric. It should be visible. Its header will be tab. Its width will be 5% of the width of the screen, and I can indicate whether I need it horizontally aligned or not, and I can also provide a data format. So in this particular case, I want my tab with a format where it's having a leading 0 if the number is less than 10. So if I go back, look at my field definitions again, I can see there's my tab. Here's where row comes from. If I'm looking for a field in here called XML element, I can see that in column 4, I'm going to have a field name called XML element. So again, this is an XML field name equivalent from the table. So if I go and look at my table here, I should be able to find that I have an X element column here. So this name here is going to be an XML element name from the database, and that XML element name follows the normal XML element naming rules, so no spaces, etc. And that is then mapping as my XML field name here. This column header can be anything you want, and essentially what we now have is a table of field definitions where we're using a custom getList command to pre-shred and filter using a lookup table all of the field definition XML, and then providing a more complex rendering of that field information by specifying which columns we want on our child list, how wide the columns are, and the data format and the actual XML field that we're basically trying to display on the table. Now, one column that you're not seeing here that's always added to these tables is the instance GUID column. So that is basically added as an invisible field to the table, and it's used that when you click a row in the table, the instance GUID is the thing that's navigating you to the next form. Okay, so in summary then, what we're looking at in this table is the result that we've just been looking at in that field definitions child list. We can see we have a tab column, a row column, a field column. The fourth column is the XML element name, and so on. So what we have is a capability is that when we're rendering a general form and we're looking at fields in the form, we're doing that on a row by row basis. So one form equals one row out of the database, and we are reading and saving changes on an instance by instance basis. So when I'm looking at the form definition record, I can see that this instance data is spread over multiple tabs. On the overview tab, I've got individual XML elements that correspond to fields in the form definition record. I then have tables of child instances that are referenced by that particular record, and those child instances are using the getList functionality. If I just need a simple list of instance names to look at my child records, so for example here I'm looking at the list of allowed states or the allowed events of a form definition, then I can just use the child list, and all I need to specify is the concept type of the records I want to create. So in this case here, the concept type would be allowed state. Here it would be events. If I want more complexity, then I'm going to use the getList function that potentially was either auto-generated, so it's pulling the information from the views, and then I'm going to specify a column list. So if you remember our example here on the data model table, I can use either the default getList function, so get ZSO field definition, to operate from the view of all of the shredded XML data and use that to populate this table. Or, as I did in this particular case, I can optimize that retrieval process because I do it so often and use a lookup table and then a custom store procedure with the same parameter specifications to return the records faster. And then those records that are being returned from my getList function, I'm using the column definitions to indicate what columns I want in my table. So this gives us a very effective CQRS, command query response separation, of the functionality that enables to read and write individual records into the instances table, and the ability to query that instances table to retrieve sets of records either directly from the instances table or indirectly through an optimized lookup table and associated stored procedures.
To learn more about GreatIdeaz products and solutions, visit GreatIdeaz.com. That's GreatIdeaz with a Z.com. Thanks.